Welcome to this edition's Nobel Dialogue, a series of interviews where we talk to Nobel laureates about their professional careers, as well as their paths to groundbreaking discoveries. Today, it is a great honor and pleasure to host Professor Robert Lefkowitz, the 2012 Nobel laureate in chemistry. Professor Lefkowitz was awarded the Nobel Prize in Chemistry in 2012 for discovering a group of receptors called G-protein-coupled receptors. These receptors prove to be extremely important since more than 1,000 drugs today interact with these receptors. Professor Lefkowitz was awarded his MD degree from Columbia University College of Physicians and Surgeons in 1966. After that, he began his research career in the late 1960s and early 1970s, when there was not a clear consensus that specific receptors for drugs and hormones even existed. After 15 years of hard work, his team discovered GPCRs, that is G-protein-coupled receptors, which created basically a pharma revolution. Today, Professor Robert Lefkowitz is a professor of medicine and biochemistry and chemistry at Duke University, and he has been an investigator with the Howard Hughes Medical Institute for more than 40 years. It is a great honor and pleasure to host Professor Lefkowitz, and please enjoy the interview. Hi, everybody, and hi, Professor Lefkowitz. Thank you very much for joining me in this edition's Nobel Dialogue.
My pleasure to be here with you today.
Perfect. And I would like to start with one curious thing about you. You basically wrote a book and not a research book. So I'm curious about that. So I can start with this, maybe with this question. So roughly a year ago, you wrote the book that's called A Funny Thing Happened on the Way to Stockholm, the adrenaline-fueled adventures of an accidental scientist. So first of all, can you maybe tell us what was the funny thing that happened on your way to Stockholm?
So there wasn't one funny thing. I was referring to a whole set of life experiences. I don't know if you're familiar with a very, very famous Broadway musical play called A Funny Thing Happened on the Way to the Forum.
I am not, unfortunately.
Okay, well, you should look it up. Because the title of the book is a play on that, substituting Stockholm for Forum. The music to the show was written by Stephen Sondheim, who was one of the most famous composers of Broadway musicals. He died, incidentally, just about a month ago. But he's an icon. So that's where the title was sort of taken from. And so it doesn't refer to any one specific thing. It refers more, if you've read my book, you know, there are a lot of humorous stories in there. And there are a lot of stories in there which are simultaneously, and by the way, for those listening in, there's a funny thing happened on the way to Stockholm. And it tells
and you can download it on Amazon, right?
Of my combined career as a physician, as a professor of medicine, clinical medicine, and a basic science researcher, illustrated by lots of stories, many of them humorous, which reflect my outlook on life, which is basically a humorous outlook. And in the book, I talk about what I think is the role of humor in science and how I use humor in my day-to-day life.
And obviously I have to ask the second question related to the book. You call yourself an accidental scientist, so can you maybe elaborate on that a bit more?
Yes, I had absolutely no intention of becoming a scientist. From the time I was quite a young child on, I had decided that my only goal in life was to be a practicing physician. And that aspiration animated me right through college, medical school, residency, etc. I loved science, but biology in particular, but only in so much as it informed the practice of medicine. I was a chemistry major in college, but I never anticipated being a scientist, and I never took advantage of any of the opportunities which came up in college or medical school to actually do research. I never, not once, not ever. And I would have happily gone on from my residency training to a lifetime practice of medicine and cardiology had not it been for a cataclysmic event. And that was the Vietnam War, which was raging in the 1960s when I graduated from medical school. And there was at that time a lottery draft for all men in the United States over 18, but there was a doctor draft, meaning no lottery, a doctor draft. All physicians, all people graduating medical school in the 60s and into the early 70s were drafted upon graduation. You were generally given a 2-year deferment to get some residency training, and then you went in, the Army, the Navy, the Air Force, or the Public Health Service. And except for the Public Health Service, you could pretty much be guaranteed to spend one of your 2 conscripted years in Vietnam. Now, it was a very unpopular war, and nobody wanted to participate, including myself. And the only way around it legally was to get into the Public Health Service, get a commission there, and then be assigned, if you were lucky, to one of their stateside institutions like the NIH or the Communicable Disease Center, things like that. So you can imagine how competitive it was to get those commissions. Everybody wanted them. But again, because I had always done well academically and gone to great schools, I was able to get the commission and was assigned to the NIH, where for the first year of my 2-year assignment, I flailed ineffectively and failed repeatedly. A new experience for me because I had never really failed at anything in a prolonged way before. But then eventually, probably about 15 or 18 months in, things started to work for me. And I started to get the bug. But the accidental thing that I'm referring to was that were it not for my being drafted and sent to the NIH, I never would have become a scientist. It was not my plan at all. So yes, in that sense, I very much was an accidental scientist.
Well, I think it's great that you ended up in research. So we would have missed out on a lot of things if you didn't end up in research. So great,
well,
great for that. Great for that. And you spoke about wanting to be a clinician and then basically went into research. But how important do you think research is for clinicians specifically? And just maybe to add to that question, on the other hand, do you think that maybe MDs who only do research are also missing out on something in the clinic?
Yeah, I think my own view is that every clinician would benefit from having had at some point in their career, hopefully early, a research experience. In fact, the Duke Medical School has for, I don't know, 75 years, I don't know how far back this goes, basically required every 3rd year medical student to spend the entire year in a laboratory. So basically, we only have the 3 regular years of medical school. First year is basic science, 2nd year is clinical rotations, 3rd year is research, 4th year is advanced clinical work. And the students, most of whom, of course, wind up going into full-time clinical careers, always speak very highly of the experience. It gives them an ability to understand. I mean, basically, as a physician, a practicing physician, you're going to be reading medical literature your whole career. I mean, if you have to rely on what you learned in medical school, you and your patients are in big trouble, as you know. So you have to learn to read articles critically, to know how to evaluate data, and draw your own conclusions. You need to be a lifelong learner. And so an experience in research, I think, is very important for all clinicians. That they actually go on to do research, I don't think that's important at all. I think if that interests them, I think we all spend so much time preparing for our careers that I think we owe it to ourselves to try to choose selfishly what we think will be the most fulfilling and gratifying career. I had thought that was going to be as a full-time clinician. But as I look back on my, at this point, very lengthy career, it's hard for me to imagine that I personally would have derived as much satisfaction and fulfillment from a career as either just a physician or just a scientist. For me, the two different roles basically fulfill different aspects of myself.
So basically, you're saying it's up to the individual.
Absolutely, we're all very different, and what works for one won't work for the other. So yeah, I was fortunate that I had that experience, because otherwise I would never have known how fulfilling the research can be to me. Yeah.
And speaking of your research career, maybe we can start from the beginning, and specifically from beta adrenergic receptors and GPCRs. So maybe can you tell us how you got into that field specifically back in the late 1960s and maybe the early 1970s?
Yes, I was again very fortunate. Serendipity sort of graced me again. I was assigned to the NIH to work with two scientists. They were endocrinologists. Jesse Roth and Ira Paston are their names. And at the time, there was no general consensus that receptors, as we understand them today, even existed. Okay. They were more of a sort of a theoretical idea or a concept. But Roth and Paston had the idea, and there were no ways to study them, much less prove they even existed. But Roth and Paston had the idea that maybe you could take radioactively labeled hormones or drugs and get them to stick to the receptor sites in membranes, in cell membranes, and sort of have a way of tagging them so that you could begin to study them, which had never really been done. So I spent my 2 years at the NIH under their direction trying to develop such an assay for a particular receptor. It was the receptor for a hormone called ACTH, which stands for adrenocorticotropic hormone, which stimulates the adrenal gland. And in the end, after much difficulty and many failures, I succeeded and published my first couple of papers. And then I went on, but I left the NIH despite their entreaties to stay on. They thought the project was very hot at that point and that I really should continue it. But I wanted to, although I was beginning to see the fulfillment that I could get from a successful research project, I still wasn't convinced this had anything to do with what I should be making of my life. So I went off to Boston to finish my clinical training at the Massachusetts General Hospital in medicine and cardiology. And after 6 very intense months of full-time clinical work, I realized that I missed the laboratory, and that I said, I really need to incorporate the lab somehow into my career. So I found in the lab of the chief of the cardiology division, Edgar Haber, a spot. And he pretty much said I could work on whatever I wanted to work on. So I thought about it. I was very intrigued by the whole idea of receptors, but I wasn't becoming an endocrinologist. I was becoming a cardiologist. So-called beta blockers were just approved for use in the United States, the very first one, propranolol. So I, as a young aspiring academic cardiologist, I was looking I wanted a receptor. I wanted a receptor coupled to the enzyme adenyl cyclase, which makes cyclic AMP. That was true of the ACTH receptor. And at that time, probably a dozen or 20 other hormone and neurotransmitter receptors. And I wanted something that had something obvious to do with cardiovascular medicine. And that, together with the recent advent of beta blockers, said to me, why don't I work on beta receptors? And that's how it all got started. So then I said, okay, now I'll go back to the beginning. Can I develop an approach where I radioactively label something and get it to stick to a beta adrenergic receptor? That turned out to be quite difficult. And through my 2.5 more years that I had in Boston, I never really succeeded. I went down a number of blind alleys and fooled myself several times. But in the end, I moved to Duke in 1973, and within a year we had it working, and everything took off from there.
Yeah, yeah, and you mentioned you went to Duke to start basically your lab, and can maybe share with us some unexpected challenges that you faced when you started your lab that you maybe didn't even think would be challenges or problems.
Yeah, so there were challenges, but there were also unexpected pleasant surprises. To turn it around, one of the unexpected pleasant surprises is that since I had been publishing at that point for a few years, a number of students and postdoctoral fellows came asking to work with me. I was very junior faculty. I was 30 years old when I started my laboratory. And yet here came, a handful of what would turn out to be superstars, and they wanted to work with me. So that was something I hadn't anticipated. I thought I'd pretty much be on my own for a few years. So all of a sudden, here came these excellent students. Unexpected challenges. Well, I can't say how unexpected it was, but I mean, probably the single biggest challenge of being a scientist is that most things you try don't work. I mean, it's failure after failure after failure. Every once in a while, something does work. But, the overwhelming majority of times, it doesn't work. And so we just had lots of failures. But in the end, things really sort of came around. And once things started going, boy, they really took off. I mean, after the first year, I would say, it took us about a year to really get our feet under us. But once we did, wow.
It really took off. Yeah. And basically speaking about publishing papers, and you try to test one hypothesis, it doesn't work, then the second one, third one, fourth one, it doesn't work. I mean, do you think there's a pressure to publish in academia, even though you can maybe work for a few years and you can't maybe get the hypothesis right, so you don't have material to publish? So can you really speak about that pressure? Did you ever feel that pressure to publish in academia, and especially maybe competitiveness in academia, which isn't all too often mentioned, I think?
Well, yeah, I mean, absolutely. I think everybody in academia does. And, it is competitive to the extent that you work on important and exciting projects. The greater that's true, the greater it will be true that it will be competitive. Because in general, the important scientific problems are not just obvious to you, but they're obvious to other people. And they're challenging. So there's tremendous competitive pressure. And I am inherently a very competitive person. So I felt that. And in the book, I talk at a number of points on just how competitive science can be. And yeah, it was very stressful indeed. Now, did I ever feel pressured to publish things that I wasn't, sure of? Well, of course, but of course one tries to be as rigorous as one can. And in general, once you publish something, you can't take it back. It's out there for all times. So yeah, there is a lot of competitive pressure, and you have to try to deal with that. I mean, it's a reality in academic medicine. And the old saw, publish or perish. If you're in a tenure line, that's true. Yet it's just a reality that in tenure track academia, you don't get a lot of credit for teaching. It's sad, but true. But yeah, you're evaluated primarily on your research accomplishments.
Yeah, and if many people are working on the same problem, how important do you think is it to publish first the discovery you made? Is it that the most important part? And does that mean that immediately all the other people's work on the same topic is less valuable, or how do you view that part?
Yeah, so the most important thing is to be right. Okay. Because if you're first, but you're wrong, that's not good. But the best thing is to be right and be first. And there is no denying the fact that the credit for any given finding, the credit that goes to the people who were first is a huge fall off to the person who was second. Okay, now there's the issue of, you know, if you publish on Monday and somebody publishes on Tuesday, well, most people will regard that as, how can I put it, basically simultaneous publication. But if there's a 4 or even 6 month gap, yeah, I mean, that's just the reality of it. The credit that will go to the people who were second is not that much. It will be said they published a confirmatory paper. Yeah. I mean, that's, you know, that's damning you with faint praise. Oh, yes, he confirmed the major finding of Alen that such and such and so is true, that you need a good night's sleep, you know, or whatever.
Well, you were the first one regarding G-coupled protein.
We were. So. That's exactly true. And, you know, in my heyday, for, you know, essentially all the important scientific discoveries that we made, we were first. And, you know, I think that reflected a number of things, not the least of which is that I was such a competitive son of a gun. And I wanted to be first. I mean, I was just listening on the news a couple of hours ago to the thing that Tom Brady, the football player.
I know.
He turns out he is retiring, which was announced days ago and then taken back, and now he really is retiring. And they were talking about, you know, what made his career so successful. And apparently one of the factors he himself credits is that he was extraordinarily competitive. I mean, he just was competitive. So, you know, I'm not saying you have to be cutthroat. That's not a good thing. I have had other scientists, colleagues, with whom I was engaged in intense scientific competitions where our personal relationships deteriorated and we viewed each other as enemies. And I have had situations with equally intense collaborations, equally intense competitors, where the opposite was the case. We became very good friends and remained friends for years, even throughout the competition. It was like a friendly competition. So, yeah.
And in 2012, you were awarded the Nobel Prize in chemistry because you were the first one to discover GPCRs. And I mean, we all know, maybe some people are not aware how many GPCRs there are in the, you know, in the human body. Is estimated, I think, around 1,000 or so different.
That's correct.
GPCRs, and like so many drugs interact with them. It's incredible how many people are actually taking drugs.
They anywhere from a third to a half of all FDA approved drugs are said to work through G-protein-coupled receptors. I take some myself. I'm very happy that we have them.
And I mean, it's quite obvious that this has caused basically a pharmaceutical revolution. I mean, these GPCRs. But on the other hand, what would you say are the downsides, if there are any, of this huge success of discovering GPCRs and drugs that interact with them?
I would have to say, in all honesty, I can't imagine what the downside would be. I mean, it's all good. Everybody has access to these drugs. I wish many of them weren't so expensive, but there's nothing I can do about that. But I don't see any downside to it. I think it's great. And nothing could be more gratifying to me personally than to have had a role in this, especially since it was never my intention to develop drugs. I just wanted to understand certain things. Were they receptors? If so, what are they? How do they work? How are they regulated? Do they play roles in diseases? But all the other stuff sort of flowed, but not it was not my original intent. So that's another thing about doing fundamental research, that it often has consequences and implications far beyond what you might have imagined at the time you were doing the research.
Yeah. I mean, I completely agree. And speaking of the Nobel Prize, I think many people probably ask you this. How did it change your life? I mean, can you share with us like the most unexpected things that happened to you after you won the Nobel Prize?
Well, there is no doubt that winning the prize does change your life.
For the good or for the bad?
I would say in my own case, it was all good. First of all, it changes your name. So my name went from being Bob Lefkowitz to Nobel laureate Bob Lefkowitz. So I'm never introduced in any context without having that Nobel Prize moniker in front of my name. It also gives you a license to pontificate about any subject at any time, regardless of how little you know about. Okay, and that's kind of fun. I get invitations to speak at meetings you wouldn't believe. I had one early on after I won the prize of a professional society which specializes in female urinary incontinence. Which is not a funny
Very
subject
related.
They wanted me to be the keynote speaker. And
did you accept it?
I did not. I told them that I didn't have sufficient expertise in the subject to feel I was a worthy speaker. They said they didn't care. The fact that I had a Nobel Prize was all they wanted. You do get things like that. But yeah, people pay you more respect than you deserve. You find that with your papers, you get more credit when they have something good in them that you deserve, and more blame, perhaps, than you deserve. And there is one downside is, certain people have a contrarian personality, and if they can possibly attack a Nobel laureate, I mean, there's a lot more juice in that than attacking somebody nobody ever heard of. So if a guy publishes a paper saying, he publishes a paper saying Nobel laureate Bob Lefkowitz is full of what, because of what he thinks on this subject, that's going to get a lot more attention than if he says your name.
Exactly. Yeah.
People will say, well, who's that?
Exactly. Yeah, I mean, it has its upsides and downsides, but I think overall it's better to get the Nobel Prize than not to get it.
I'll take it. It's really it's an amazing experience. I have a whole chapter in the book about what that experience in Stockholm, which is not just the day of, but it's about 10 days that you're in Stockholm in early December, culminating with the award of the prize on the 10th of December, which is the anniversary of Alfred Nobel's death. I feel so badly for the last two classes of Nobel laureates, 21 and 20, which had to do it virtually. And I mean, the pomp and ceremony is just so incredible. I really feel badly for people who.
Well, hopefully this year they're gonna go to Stockholm. Hopefully.
I hope so.
Yeah, and speaking of people going to Stockholm, do you have any discoveries in mind that maybe deserve a Nobel Prize but haven't been awarded one yet?
You mean, are you asking? Are there people I see out there who I think should get a Nobel Prize?
Exactly.
Yeah, absolutely, there are several, but I'll just mention a couple. One is Jeff Friedman at the Rockefeller University in New York, who discovered leptin, this hormone that is produced by fat cells and which has an important role in all sorts of metabolic regulation. I really think he deserves a Nobel Prize. And another one would be Carl Deiseroth. You must know of him, UCSF, who basically developed this approach. What's it called? Optogenetics.
Exactly.
Optogenetics, yeah. And he would probably receive it with several of his predecessors who discovered these light-sensitive channels that he then made use of to develop optogenetics. Another one would be Ron Evans at the Salk Institute, perhaps together with one or two others, who really discovered the steroid hormone receptors. Those are all people that, you know, there have been studies of this. It turns out that the lag period between the time somebody does their most important and seminal research and the time that they are awarded the Nobel Prize has been getting longer and longer and longer. And that's true in all of three of the scientific disciplines. Currently, it's close to 25 years. And that was certainly true in my case. It was 20 to 25 years. But for each of the people I mentioned, I guess the one that's the shortest time frame, if it was awarded now, was Deiseroth, who did his work 2005 or something like that. So that's not even 20 years. So that should be a while. But the others that I mentioned are easily in that 25-year window already. Now, there are exceptions to that. The CRISPR was much sooner, okay? Or if you go back to something like Watson and Crick for the double helix, that was much quicker. But by and large, it's a long wait. And I've been amazed at how long these folks have been waiting.
Well, maybe this is their year. You never know.
Maybe this is their year. I'd like to go back one time when somebody wins that I know well, just to just experience the whole thing again, but not as somebody who's in the glare of the spotlight myself, but to just sort of sit back and watch and enjoy it. Because it is an amazing experience. And as I say, I've got a whole chapter about that in the book.
Yeah. And I mean, I suggest everybody reading it because you're a great storyteller, as I mentioned.
Thank
I think
you.
people can already tell that. So yeah. And now maybe moving on to the last part of the interview, away, if we can, from the Nobel Prize. I just want to get your thoughts maybe on open access science, because there are many journals that you have to pay quite a lot maybe for open access, and not everybody in the world has maybe the financial independence, let's say, to actually pay for it, or universities are maybe not as financially powerful to pay for it. So do you think maybe open access should be the norm, or maybe do you see like negatives to open access?
I see no negatives. I see no negatives at all, and I guess I don't have a lot of original thoughts. I've looked through your archives of interviews, and you could not have had a more appropriate guest to discuss that than Randy Sheckman, who's a good friend of mine. And Randy really has done so much for open access publishing, and has served so selflessly as an editor of several journals. I mean, he's just a real hero in terms of what he's done. All I can say is, like most scientists, I completely support it, and wish it was universal. I just can't imagine how frustrating it must be as a scientist when you're trying to track something down in the literature, and you hit on it on your computer, and then you can't get to it unless you're willing to pay, and that just seems to me antithetical to everything we're trying to do.
I mean, I completely agree with that. So yeah. And speaking of your research and your citations, so I've seen that you're one of the most highly cited researchers in the field of biology and clinical medicine. But I wanted to ask you something maybe on the complete opposite end of that incredible achievement, basically. And that is, what advice do you have for people who are just starting to get into research? I mean, young scientists, young physicians. Do you have any advice for them that you maybe learned over your life?
Yeah, I would say, and this was always something difficult for me, be patient. Be patient.
Mm-hmm.
In the end, what matters is what you publish, not how many papers you publish. So especially at the beginning, there's a tendency to become impatient, but try to hang on, try to be patient, and try not to publish what you sometimes hear referred to as MPUs, minimum publishable units. Yeah, I mean, the thing is, the reality is, in this day and age, everything is publishable. Everything. Okay. There are so many journals pleading for articles. I read something somewhere that the fraction of all papers that never receive a single citation in the world is a very high number. It might be at least 50%. I forget the exact number, but it's hard to imagine. I mean, that
exactly.
50% of papers, or whatever the number is, never receive a single citation. So yeah, I think, you need to keep your powder dry and really wait until you have something to say before you just go out and start publishing.
So exactly. So be patient is the message.
That's the message.
Are there maybe any key skills that a young research scientist should have in order for him or her to become successful? Maybe.
Well, that's a lecture in its own right. It really is. And again, in my book, I have a whole chapter on my mentoring advice. Suffice it to say that I think the most important and potentially transformative experience for any budding scientist is to apprentice themselves to a really, really good mentor. Because that's where you learn the special sauce that goes into doing high-level research. You can't look that up in a book, although if you're going to try, I suggest mine. But basically, the keys to doing outstanding research are subtle things that you learn by watching a mentor. And that's probably, I think most young trainees misunderstand what the most important decisions are that they're going to make in their career. They think it's where they go to college, or where they go to graduate school, or where they do their postdoc. And none of that matters much. What matters is who your mentors are. Okay. Those are crucial because it's from the mentor that you really learn how to choose important stuff that you can't look up in a book. Like, how do you choose an important scientific problem?
Yeah.
Important, but tractable. Or at least tractable to you, which is really all that matters. How do you decide when you get an unexpected finding? How do you decide when to put the blinders on and not get distracted and just keep heading for your goal, as opposed to get distracted and say, well, wait a minute, maybe this is something unexpected and very interesting. Or when do you stop a project that's just not working and say, we just can't do this right now, let's move on to something else, as opposed to saying, well, let's back up, let's take yet another run at it. I mean, I'm not finished with this yet. So it's all of these kinds of things. And the best way to learn that is by watching an experienced and talented mentor make these decisions over and over and over again over a period of years when you're in their laboratory. And of course, in order for that to work, the mentor must be transparent and must make themselves available and let you watch how they do this. If they're doing this behind closed doors or in a different office, in a different building, or on a different floor, you don't get to see it. So to me, that's the most important thing.
Yeah, I mean, I think that's great advice. Be patient and find a great mentor. I think that combo is unbeatable.
Exactly.
Yeah, and we're basically at the end of the interview, and of course I have to ask you 5 quick fire questions. So short questions, short answers. So are you ready?
Yes, throw them at me.
First one, your role model.
Well, since there are two aspects to my career, clinical medicine and research, I've had different role models. I would say my role model in clinical medicine is a gentleman by the name of Dr. Roman DeSanctis. He's in your neck of the woods.
Okay.
One of the most famous cardiologists ever, was one of my mentors at the Mass General, practiced medicine in a way that was unbelievable. I've never seen anybody before or after. His level of involvement with his patients was just unbelievable. Plus, he knew everything. So he's 91. He's a good friend of mine to this day. And he lives in Boston, but he is retired. And he didn't retire till he was 83 or 84. I guess, we think of role models as being people older than us and from an earlier generation, but not necessarily true. Two of my scientific role models have always been contemporaries of mine, Mike Brown and Joe Goldstein, who discovered the LDL receptors, for which they won the Nobel Prize, probably somewhere around 1985, at a very young age, in their early 40s. So there's a rigor and originality to their research that I've always found so admirable and been inspired by. And so I would say on the scientific side, and they're both physician scientists like myself. So I would say on the scientific side, I would choose them.
Second question, best advice you were given?
Best advice I was given. Again, I got two things. One was at the height of my despair at the NIH, when I really was thinking that no way I could be a researcher at all. I had decided to pursue clinical medicine. So I went up to the Mass General to interview for a position, a year later as a resident and then a cardiology fellow. And I was interviewing with a man named Charles Sanders, who was at the time the head of the cath lab at the Mass General. And he would go on to a very distinguished career, first as head of the Mass General Hospital, and then a big executive, I think at GlaxoSmithKline. And he asked me what I wanted to do. And I said, I wanted to get as far away from what I was doing right now as I could, that I would like to be like him. I would like to be an interventional cardiologist and do catheterizations. He listened. He said, terrible idea. He says, I'll never forget his words. He said, Bob, he says, guys like me are a dime a dozen. He says, but you're onto something of trying to apply biochemistry to cardiovascular disease. He says, stick with it. Don't jump to hemodynamics or whatever. Stick with your biochemistry. So that was probably one of the best pieces of advice. The other one came from a senior scientist at the NIH. Wasn't so much advice, more, it really was in a sense. It was opened my eyes to something, sort of an attitude that I should have. I was at the depth of my despair toward the end of the first year of nothing working. I was having lunch and he came over, and he was not my mentor, but he worked down the hall. He said, Bob, he says, do you know what percentage of experiments actually work or give interesting information for your average scientist? I said, no. He says, it's about 1%. He says, now, what do you think the percentage is for an absolute world beater, a Nobel laureate? I said, I don't know. He says, it could be as high as 2%. And that raised my awareness of the fact that even for the most successful researchers, the overwhelming majority of everything they do fails. And I would say, now that I'm a Nobel laureate, I can confide that for me, that 2% figure is probably a little high. Okay, it's not that good.
Yeah. The third question, one bucket list thing that you want to do, something unusual, maybe even crazy?
That is a very short answer. I got no bucket list. And if I keel over right now, which I'm really hoping I don't do, at least for your sake, not before the end of the interview anyway, there's really nothing in particular that I feel that I want to experience that I have not experienced. I have been so blessed in my life, a wonderful marriage, 5 children, grandchildren, my career, which has been a delight for me, the opportunity to practice medicine, at least for a while. I haven't, I basically hung up my stethoscope about 10, 12 years ago. So yeah, I got no bucket list.
Okay. Fourth question, favorite book, and that doesn't include your book.
Right. Well, okay. So you took that away. That's definitely the favorite. But the interesting thing is, I read very little fiction. Okay. Almost everything that I read outside, my scientific purview is nonfiction. But my favorite book, for several reasons, is Don Quixote by Cervantes. This wonderful novel of this guy who's under the delusion that he's a knight and goes off to fight all these battles. I love that novel. It's very long, about 1,000 pages. I was reading it on the day that I got the call from Stockholm. I was on about page 500. And my life turned upside down. For the next 2 years, things were so crazy, I didn't read a page. But then about 2 years later, I came back to it and I finished it. And it was just a joy. It just, I don't know, something about that book and the grand dreams and schemes this guy has and the sense of humor. Yeah, that's my favorite book.
Cool choice. And the last question for the end of the interview, writing books or writing research papers? You have to choose one.
I would say at this stage of my career, writing books would give me more pleasure because, I've written a lot of papers. I've only written one book. And of course, the problem is, in terms of the science, I got a lot more coming. We have a lot of papers we're going to write, that we are writing, that science is going on. In terms of books, I'm not sure I got much more to say, but we got a few stories that didn't get put into the book. So maybe there'll be a sequel, but I think that was a lot more fun, put it that way. I really enjoyed writing the book with my co-author, who was a former trainee of mine. So.
Great. Thank you very much, Professor Lefkowitz, for this great interview, for your time. And I have to mention, of course, once again, the book. And one thing I noticed, the amazingly cute teddy bears below the book. So I have to mention
yes,
that too.
Indeed. All right. You're right there. Exactly. These are
2 of them.
Teddy bears that I used to give to my wife.
Okay.
If I was giving her a gift of jewelry, okay, a particular local jewelry store would put the gift inside the teddy bear.
Oh, I see.
Okay. And so over the years, she collected the teddy bears.
Cool. Thank you very much, Professor Lefkowitz, for this great interview. It was a real joy to talk to you.
Well, my pleasure indeed, Alan. Thank you.
Thank you very much.